Hello and welcome to our 8th and final training video designed to provide insight into the purpose, properties, uses, and equipment surrounding R-1234yf. This video builds off of our last video about the refrigeration process by looking at the high pressure side of the system. Here we have two diagrams that show the flow of refrigerant through the 1234yf system. Our last video covered the blue, low pressure lines up until the compressor, where vapor pressure is increased. After the compressor, we have the condenser. In the condenser, the refrigerant undergoes a phase change from a gas to a liquid. Outside air passes over the condenser coils and absorbs heat from the refrigerant, which causes it to cool down and condense to a liquid. This high-pressure liquid leaves the condenser and moves towards the receiver dryer. Now we have the receiver dryer. The receiver dryer stores and separates the refrigerant by filtering out any moisture from the liquid refrigerant. Any residual moisture that isn't meant to be included with the refrigerant is removed so it doesn't cause any problems throughout the rest of the system. The liquid refrigerant at the bottom of the receiver dryer is sent to the second pass of the expansion valve that we briefly mentioned in our last video. Now we are at the expansion part of the H-block thermal expansion valve. The high pressure liquid coming from the condenser and the receiver dryer is forced through a small metered orifice that causes liquid to quickly expand, which lowers its temperature and pressure. The amount of refrigerant that passes through is controlled by that sensing element that we mentioned in our last video. It is crucial to have a low pressure heading into the evaporator so that we can have that all-important phase change from a liquid to a gas. 1234yf systems also contain an internal heat exchanger that most 134a systems don't have. This is meant to add efficiency and doesn't have any moving parts. It works by increasing contact between the refrigerant and different parts of the system so there is more heat transfer. The high-pressure liquid refrigerant from the high side flows through the outer shell of the tube and is cooled before entering the expansion valve, while the low-pressure gaseous refrigerant is heated before heading to the compressor. To summarize, this heat exchanger is included in YF systems to reach higher efficiency levels. That's all we have for you for this video and for our training series, so thank you for joining us for an introduction to the high-pressure side of a 1234yf system. And we hope that you have learned valuable information regarding 1234yf throughout our training series.